For as long as you've been alive, the science has been settled. In a few billion years, the Milky Way is going to slam into the Andromeda galaxy. Our two galaxies merge into one. The night sky is rewritten, and it's called Milkomeda. You've probably seen the simulation, but in the last year, that certainty has fallen apart, and then partly put itself back together. Our galaxy's fate flipped from inevitable to a coin toss and back toward likely. Not because the universe changed, but because we finally started measuring it properly. And the honest answer right now is that we do not know. So what happened to the most famous prediction in astronomy? First, why everyone was so sure? Andromeda is our nearest large neighbor, about 2.5 million light years away, and it's falling towards us. Astronomers have known it's approaching for over a century. In 2012, using the Hubble Space Telescope, a team measured not just how fast Andromeda moves towards us, but its tiny sideways drift across the sky. And that sideways motion looked small. A small sideways motion means a nearly head-on approach. Head-on means collision. That measurement locked in the textbook answer. A near certain merger in about 4 to 5 billion years. And it became one of those facts everyone absorbed. Our galaxy is doomed to merge. The sun will still be shining. Earth may still be here. And the sky will fill with a second galaxy on final approach. It was settled, as settled as astronomy gets. Textbooks printed it. Documentaries animated it. A whole generation grew up knowing, as a simple fact, that our galaxy has an expiration date and a name for what comes after. Here's the catch that was hiding underneath the whole time. That sideways motion, the transverse velocity, is one of the hardest measurements in all of astronomy. You're trying to detect a galaxy 2.5 million light years away, drifting sideways, by an amount so small it's like watching a human hair move from kilometers away. Get that number even slightly wrong, and the entire prediction swings from a direct hit to a clean miss. For years, that measurement had big error bars, and the collision answer sat inside them comfortably. But the game changed with the European Gaia spacecraft, which measures the positions and motions of stars with staggering precision. And in 2025, a team led by Til Sawala took the newest Gaia data and did something the old predictions hadn't. They added the rest of the neighborhood. We hadn't been modeling a two-galaxy problem. Reality is a whole crowd. Because the Milky Way and Andromeda are not a tidy pair drifting toward each other in empty space. They sit inside the local group, surrounded by smaller galaxies, and two of those matter enormously. One is the Triangulum Galaxy, M33. The other is the Large Magellanic Cloud, the Milky Way's biggest satellite. These aren't bystanders. Their gravity tugs on the giants, nudging the orbit. And here's the twist Sawala's team found. The Large Magellanic Cloud pulls the Milky Way in a direction that runs perpendicular to the collision course, sideways to the whole Milky Way Andromeda orbit. That sideways tug is small. The Large Magellanic Cloud is only about a tenth of the Milky Way's mass. But over billions of years, a small nudge in the right direction is enough to turn a collision into a near miss. When they ran 100,000 simulations across the full range of uncertainty, the near certain collision collapsed into a coin toss. Roughly a 50-50 chance that over the next 10 billion years, the two galaxies simply pass each other and drift on, never merging. The doomed galaxy headline of the last decade was suddenly only half likely. For a moment, it looked like we might dodge the collision entirely. So, is our galaxy saved? Not so fast. because this is where the story gets genuinely honest about how science works. The coin toss result depended entirely on that brutally hard sideways motion number. And in early 2026, another team, led by Hao Wu, went back to the same problem with an even more refined set of Gaia measurements. Proper motions of Andromeda's stars, corrected for subtle systematic errors in the spacecraft's own data. With that sharper number, the pendulum swung back. In their model, the merger probability climbed to about 90%, with a most likely collision time around 6.5 billion years from now, broadly restoring the classic picture everyone grew up with. Doomed again. Except, and this is the part that matters, even this team was careful to say the measurement still isn't good enough to be sure. Push the Andromeda motion to the edges of what's currently allowed, and the merger probability still swings anywhere from about 65% all the way to near certainty. The honest headline isn't "we're saved" or "we're doomed." It's that our galaxy's fate is balanced on a measurement we haven't yet nailed down. In a single year, our galaxy went from doomed to spared to probably doomed. And we changed, not the sky. Now, before this feels like pure suspense with no stakes, here's the part that's often left out, and it's not in doubt at all. Long before Andromeda's fate is decided, the Milky Way is going to do some devouring of its own. That large Magellanic Cloud, the satellite currently helping us to steer us off Andromeda's path, it's on a decaying orbit. Our galaxy is very likely to tear it apart and swallow it, possibly within the next couple of billion years, long before any Andromeda encounter. And there's an even more certain ending waiting closer to home. Whatever galaxies do, our Sun has its own schedule. In about 5 billion years, it will swell into a red giant, likely swallowing Mercury, Venus, and possibly the Earth. As one of the researchers bluntly put it, the death of the Sun is far worse for our planet than any collision with Andromeda. The galaxy's merging is a slow, majestic reshuffling of stars across billions of years. Almost nothing actually crashes into anything, because space is mostly empty. The end of the Sun is the one that actually ends us. So why tell a story with no final answer? Because this is science caught in the act of correcting itself, in real time, on the single most personal question it can ask. What happens to our own galaxy? For 100 years, the answer was a confident yes. Better instruments turned that into a maybe. Better still turned it back toward yes, but an honest yes, with the uncertainty shown rather than hidden. That's not a failure of science. That's the opposite. A field confident enough to overturn its own textbook the moment the data demands it. And the deciding measurement is coming. The Gaia mission's next data releases, and the surveys after it, will pin down Andromeda's sideways drift to a precision that finally settles which future we're in. We may be one data release away from knowing, for real, whether our galaxy has a partner in its future, or passes it in the night. We are quite possibly the first generation that will actually know how this ends. So the next time you see that confident simulation of the Milky Way and Andromeda merging into one, remember, that isn't a prediction anymore. It's a coin still spinning. Our galaxy's destiny turned out to hang on a motion so small we're only now able to measure it. And depending on the year you ask, we were doomed, then spared, then doomed again. The universe didn't change its mind. We just finally opened our eyes wide enough to look. This channel is about exactly these moments. where something everyone treated as settled is quietly alive and unresolved. If you want to be here when the measurement finally lands, subscribe and stick around. Until next time, clear skies.